Let's go through this question now. So we have a function on three variables, and now we can differentiate the first order and the second order partial derivative with respect to x, y, and z. So that's going to be good training right now. Let's do it with respect to x first. F derivative with respect to x, that's going to be every part differentiated with respect to x means that x is the variable of interest, y and z is going to be our constant. So let's do it. E to the power of x plus y derivative with respect to x plus x squared times y derivative with respect to x plus z cubed derivative with respect to x minus y times z derivative with respect to x. Okay, e to a power, we keep it the same, but then we don't have just the power of x, we don't have just the variable of interest, so we have to use the chain rule, x plus y derivative with respect to x, plus, what did we say here? We have a product times a constant, because y we treat it as a constant. Take the constant out first. Now let's differentiate x squared, that's just going to be 2x, plus z cubed derivative with respect to x, that's just 0, because it's a constant derivative, minus y times z derivative with respect to x, again, this is a constant, this is going to be an actual number in result, so the derivative is 0, which means we have e to the power x plus y derivative with respect to x is just 1, because x derivative is 1, plus 2xy, and that's it. Now we got f derivative with respect to x. Let's work with the second partial derivative right away. So let's do f derivative with respect to x, and let's differentiate it once again with respect to x. So we will take the first partial derivative, which we just found, e to the power x plus y plus 2 times x times y derivative with respect to x again. So that's going to be e to the power x plus y derivative with respect to x plus 2 times x times y derivative with respect to x. Okay, what is e to the power x plus y derivative? Let me go a bit down to have some space. That's just e to the power x plus y times the power derivative, because of the chain rule once again, plus 2 times x times y derivative with respect to x, that's just the constant, which is 2 times y. We take it out. So as a result, we have e to the power x plus y plus 2y. So that would be the second partial derivative with respect to x. Now let's do the second partial derivative with respect to x and then with respect to y. Let me zoom out a bit so we have the big picture. Something like that. Yes, we need to keep the first derivative with respect to x because we'll still use it. So let's do it x and y now. F derivative with respect to x and derivative with respect to y. So we take the first partial derivative with respect to x, e to the power x plus y plus 2 times x y derivative now with respect to y, because that's the second partial derivative. So we differentiate every term with respect to y now, with respect to y, and then 2xy derivative with respect to y. So we have e to the power x plus y times the power derivative with respect to y plus, what do we have here? We treat y as the variable of interest, so everything else is a constant, meaning that 2 times x is a constant. So as a result, we just have e to the power x plus y plus 2x, because x plus y derivative with respect to y is again 1. It's just 0 plus y derivative is 1. And it's a very good thing to write the derivatives, what we're differentiating, always. Like down here, keep this index because it's easier to keep track what we're actually doing. And now if we do the partial derivative with respect to x and then with respect to z, we will have the first partial derivative with respect to x and the second one will be with respect to z. So we have f derivative x and then once again with respect to z, meaning we have the first partial derivative, which is with respect to x, and then we differentiate this with respect to z. So we take every term derivative with respect to z, plus 2xy derivative with respect to z. Here we don't have any z involved, so it's just going to be a constant derivative, because this e to a certain power is going to be a number, it's a constant, so it's going to be 0. And the same here, a product is going to give us a result, which is a number derivative, that's 0 again, so the overall result is 0. Let's leave it like that for this video because it's getting too long. In the next one we'll do the same for y and then z.